Hi everyone, today I'll be giving a little bit of an introduction to the lab. I thought it might be easier to create a little video, otherwise it's very hard to see on the screen. So what we're going to be doing is I'm going to be demonstrating how MapReduce works over Hadoop streaming. Now for this you need to install a virtual machine, which is pre-installed Hadoop cluster. And you'll find the installation instructions on this Google document. I'll post a link on eDimension as well. Now, we're using Hadoop streaming. What does that mean? It means that we can use Python to run our MapReduce scripts and send them and execute them on our Hadoop cluster. So let's switch to the actual virtual machine. For this, you'll need the software VirtualBox. Here we go. And VirtualBox, I provided an OVA image.ova, which you can just import. It should work. You select the OVA system and it should work. I have one already imported, so I'll just run that device. So the virtual machine is actually quite small and a little bit older. I deliberately not updated this because then it should be easy to run for all of you. So because it has low memory requirements. Now the two most important things for you when you open this virtual machine, first is to use the terminal because that's how we're going to be communicating with Hadoop. And next is the home folder in case you want to browse a little bit what's on here. Let me open it for you. In our home folder, we see a folder called Udacity Training, and those are the data sets. The data folder contains the data sets that we'll be using in the lab, and code has the default mapper and reducer code that we will be using for the first example exercise that we'll be doing together. All right. Now, as you know, Unix, you can use pwd, print working directory, to see where we are. We are in the home folder. The username here is training. So we can move to the Udacity training folder. Oh. Okay, go away, Siri.
Okay.
All right. So first thing, so we're now in the same folder as our file manager here. Is it Dolphin or something? And we can start by putting things on our Hadoop virtual machine. So as you know, we can list whatever is in our directory, and in the Hadoop file system we do a similar command to see what's on there. So sorry, there's some stuff on there from me from last year, but let's start by putting the data file purchases onto the Hadoop file cluster. Okay. So how do we do that? We use the Hadoop put command. We always have Hadoop file system first, and then put data/purchases. Okay. Done. So let's list again what we have, and now we also have purchases.txt here. Great. Other things you can do is move using the if you look back at the slides, you could move files. If I want to move purchases to rename it, or to a new folder that you create using make dir first, you can sort of organize your Hadoop cluster in a very intuitive way. Okay. I'll leave you to experiment with that. This is all very similar to Unix commands, so it shouldn't be anything new. Okay. So review the slides on MapReduce. So remember what they do. We have a file of purchases here, which look like this, right? So we have the transaction date, time, city, order item, price, and how the payment mode. Okay. So what do we want to do? We want to get the total number of orders per store. And as we've talked about in the lecture, that means that our mapper code is first going to create, they're each going to get chunks of this text file. And the mapper is going to create nice piles per store. These piles are sort of considered key value pairs. Okay. Then the reducers are going to take these piles, which are already sorted, and get the total out of each of their piles. So how will this work in terms of Python? Okay. We have, let's go back to the code here. We have a mapper and a reducer code to do each of this. Let's just do it in command line, it might be easier. Okay, so code mapper. Oh. All right. So this is a very, very simple Python file. It starts here. You import the system library so you can use input-output commands. So mappers get a chunk of text file, and for each line in their input, okay, what do? We split them based on tabs. Because this text file we have is, each column is separated by a tab, and then we store it into a list called data. Okay, if the data length is 6, because we want to do some error checks, right, then we can name each of the column or items in data like such. Okay. Now, what the mappers need to do is output these key value pairs. Remember from the drawing, we have store, I suppose it's city name or store city, and sales of that transaction, total transaction cost. So how does the mapper return that key value pair? Using the print command, okay? And we take the norm here, but really it's up to you, that we tab separate the two values, so the store name and the cost. And that's it. That's all the mapper does. Okay. What does the reducer do? The reducer is a bit longer here. Again, the reducer gets these piles of key value pairs. So for each line in their input, they also strip the line based on the tab symbol. Remember, that's how we defined it. Just need to make sure the mapper and reducer know which separation they use. Then if we do some error check here, and if you get not a key value pair, but the input is not 2 columns, then something has gone wrong. Okay. Right, so our data mapped, in case it's 2 items, would form a key and a sale. Okay. Now, here's a little bit of logic to print out basically, to summarize the sales as long as you're looking at the same store. Okay. So the key represents the store here. And as long as the old key, the previous store, the previous line, is the same as the current store, what you do basically is you add it to the sales total of that store. Okay. And once the old key is not the same as this key, then you print previous store, the total was this, and you reset the sales total. Okay. So that's all that's doing. And that's it. That's what mapper and reducer do. Now, how it's basically Hadoop that manages all the logic behind this, right? So it'll execute it in a parallel manner. We can track our process, etc. Something that we should do, because we have our data set on there now, we need to put all of our input in a folder. Now, why do we need to do this? Because if you remember, Hadoop usually runs on a lot of data, and it wouldn't be typical that you'd have a text file that is in the order of 10 terabyte or something. Usually it would be chunks of files that come from all sorts of different stores, might send their own files, and you keep them separate. So what we do is we just create a directory, Hadoop file system, make directory, there we go. And then we move our purchases file into input 2020. Did that work? Let's see. All right, so if we now ls input 2020, then we see that the folder input 2020 on our Hadoop cluster contains the purchases file. Great. So this can contain a bunch of text files, all with the same sort of format as purchases, and Hadoop will know what to do with it. Okay, so let's run the streaming command. So what we do, we point Hadoop to our mapper, to our reducer, then to our input folder, so a folder with all of our input files in there, and then we give it an output folder. Okay, that doesn't need to exist, it will be created, and the output folder will contain the results file and log files. Okay, let's run it. Now, while it's running, you can track your progress in the terminal, but you can also go to your file browser and point to here we go, to your job tracker local host address. That's always the same, and it'll tell you what's running, how complete it is. So it's still working on the map job. Once it should start the reduced job before the full it will start the reduced job before the full map job is complete, as you see here. Okay, so this is the parallel processing that's happening. Great, let's refresh again. So this Hadoop also has a little bit of a backend, so you can have a look at how big your name nodes are, how many name nodes there are, how many data nodes there are, etc. So in this case, of course, there's only one data node because we're sort of having a demo cluster, but the principles are all the same. Okay, so how is our job tracker? Seems like it is done. Great. All right, so now what? We have our results available, which are in the output folder that we defined. Okay, so Hadoop file system list output 2020 is what I called it. Okay, and you see now some new files appeared here. Okay, great. So we have logs and we have part 000. This means the part 000 is the actual file type. Sorry, output. Okay. So in case your output is really, really long, it'll split it in different files as well. So okay. So now with this get command, I actually got the output into my home folder. I think I was in the code folder. So the data set. Okay, here we go. So we have our logs, we have part, which is the actual files, and a success flag. So now what we can do, because we have it on our local folder now, is see the output. If we visit this, we could try the output, the whole file. It might be really long. There you go. If we're looking for an actual, let's say we're looking for Rochester or Spokane, let's say Spokane, in part 001, then we can use the grep command to only get the line that we're interested in. Okay, if it's really long and you want to see if the solution looks somewhat like you expect. And you can also use the head command, etc. We'll experiment a little bit with Unix commands in week 3 lab, so it'll be useful for file handling. Okay, so this is pretty much the gist. One thing to remember, if you have an error in your mapper or reducer code, then it will still create the output directory folder. However, it'll have the error codes and the error log, which might be interesting for you to have a look at. If you're running your job again, you need to specify an output folder of a different name. So each job needs to have a unique output name. This is important. You'll get an error otherwise, right? Okay, so what we're going to do is we're going to be practicing this in the lab. If you look at the slides, you will see there's an example we went over together. And now there's going to be, in the end, there's going to be a few exercises for you to do yourself on this mapper and reducer.